Hi, everybody. Hopefully this is going to work out. I tried writing directly into the Savvas program, and unlike IXL, it doesn't allow me to do that. So basically, when I click on my pen or my stylus, it sends me to a screenshot of the problem. So hopefully I'll be able to write out the answer, explain them. My recommendation is that you attempt the assessment yourself, of course, and find out which ones you missed. And then if you don't know, if you guessed and you're not sure why, you should watch that segment as well. But the most important thing is to skip ahead throughout this video and find the problem that you want to see explained. Anyway, these are decimals, more or less. There's one improper fraction in the list, and basically all they want you to do is put them in order. Now, the trick for ordering decimals is to make them all the same length. Well, unfortunately, with that bar over the 0.01, that's a repeating decimal, and you can't make it the same length. It extends forever. This is a real problem. So what I'm going to do is I'm just going to make them all 4 decimal places. So I'm going to write them all to 4 decimal places. This first one, the 1.01 is 1.01. And if there's no more decimals to have, it's 0, 0. Now, you could keep writing zeros on it, but I'm going to write the next one, which is this one, 1.01 repeating, and the next two are 0, 1, and it keeps repeating 0, 1, 0, 1, 0, 1. But again, I want them to be the same length. Now, the 21 over 19, most people are going to have to go ahead and grab a calculator to do this. But I want you to notice that 19 goes into 21 one time, and then we have 2 left over. Now, you should recognize that 2 over 19 is actually larger than 2 over 20. And 2 over 20 would be 1.1. So this number is probably going to be bigger than 1.1. And let me go ahead and do that real quick for you. Oh, I should have grabbed the wrong thing. I'm grabbing my phone instead of my calculator, not too bright. All right, so 2 divided by 19 is 0.1053 if I round it. So this is 1.1053, and we want it from least to greatest. So the smallest one is right here. This is the first. This is the second. And of course, this one is the largest. Now, it makes it really easy to put decimals in order if you write them the same length. In other words, I wrote it to the 10,000th place. Notice that 100 is the smallest, 101 is just a little tiny bit bigger, and 1,052 is much, much larger. This is the fractional method for expressing a decimal. This is 1,053 over 10,000. This is 100 over 10,000. And this last one is 101 over, actually it's over 999, but it's supposed to be over 10,000. So anyway, they're in order for one of these, and I'm not going to tell you which one it is. So there you have it. Of course, you should be putting it in order yourself. Oh, maybe it did let me write on the screen. Okay, so I guess I am going to have to put the answer in. It's going to be this one, isn't it? There we go. Oh, didn't let me choose, did it? Well, let's find out. No, come on, next one. How do we go to the next one? Maybe it's this one. Oh, there it is. Okay. So the next one. This is so weird, but anyway, which statement is true? And I'm just going to see if I can write on the screen. No, it doesn't let me. So when I click on this, what it does is it creates It takes a picture and creates a little space for me to write on it. You might want to have to write on a separate piece of paper, but I need to write on the screen, so here it is. Now we want to know which of these statements is true, and it says that negative 17 is greater than negative 20. That's the first one. It says 1/2 is equal to 8 over 4. A lot of people are going to say 8 divided by 4 is 2, so this must be 1/2. It's not. This is equal to 2 over 1. So these are not equal. 1/2 is not equal to 2. One way to test fractions to see if they're equivalent is to cross multiply. And if the product is the same, then the fractions are the same. 8 times 2 is 16, and 1 times 4, I'm cross multiplying this way. Generally, you want to cross multiply up, but these are definitely not equal. 2 is much larger than 1/2, so this is not true. The next one, again, when you're ordering decimals, you want to write them the same length. So 8.0100, or do we want 8.001? Actually, I wrote an extra one, but that's okay. So 100 is bigger than 10, so it should go this way, and it's not. It's going the other direction. We're saying that 8 and 1/1000th is bigger than 8 and 1/100th, which is not true. This last one says that negative 6 over 1 is greater than negative 2 over 3. Now, when you're comparing these, it's helpful to actually get a common denominator. And in this case, it's going to be 3. So I have to multiply by 3. And I get negative 18 is greater than, and this one is already in. These are in thirds now. So really what we're comparing are the numerators. And negative 18 is not greater than negative 2. This is very confusing because negatives, this negative 18 looks larger, but it's actually more debt. One way to think of it is, do you have more money if you owe 18, or do you have more money if you owe 2? You can think of it as more change as well. Anyway, this one is not true, and the first one is true. It is true that negative 17 is less negative than negative 20. It's closer to 0, so it has more value. Lots of ways of thinking about it. This is definitely one that you need to know. Which statement about the number negative 3 is true? Natural numbers are numbers like 1. Oops, do it again. Natural numbers, 1, 2, 3, 4, and so on this is the set of what we call the natural numbers. I should write natural. These are the caveman numbers. 0 is not included. When you take all the natural numbers and you put a 0 with them, then you get the whole numbers. There's only one tiny difference between the whole numbers and the natural numbers, and that is the number 0. Doesn't seem like a big deal, but 0 was a very, very important number. It wasn't invented until India came up with it somewhere around 5000 BC. It is not a natural number. It is not a whole number. It is definitely an integer. And is it a rational number? Can you write negative 3 as a ratio? And of course, we know that negative 3 is the same as negative 3 over 1. All whole numbers, all integers can be written as ratios. So it is definitely a rational number. And that means that it cannot be irrational. So you've got rational and integer, and that's it. You should definitely do the A11 from IXL. And of course, you can watch that video and see it too. Right? Because you need to know your number systems. Next one. Which statement are true? All integers are whole numbers. Integers are not always whole numbers, because we just had an example. All you need to prove that a statement is false is a single counterexample. -3, I'm sorry, I'm going to do negative, -3 is not, we say it does not belong to the set of whole numbers. And you could write them as 0, 1, 2, and so on. This is an absolute proof that A is false. B, all whole numbers are natural numbers. The only exception is 0. That is absolutely proof that all whole numbers are not natural numbers, because 0 is not a natural number. Some rational numbers are integers. Now that one is true because in the last one we showed that -3 is an integer, but it is also a rational number. So it looks like C is true. You don't stop there. A really good idea is to keep going because occasionally there's more than one right answer. Remember that you can sometimes choose all that apply? Not in this case, but it's always a good idea to check the last one. Some irrational numbers are rational numbers. Ir means not rational. So clearly this is not true. So it had to be C. All right, you're going to add 104 to both sides, and I'm not going to do this one. In this one, you're going to do your 2 steps, and you're supposed to find K. Now, what some people are going to do is they're going to substitute in their head for K and look for the answer and test each solution. Not the way you're supposed to do this. You're supposed to solve it by doing the 2 steps. Let's do the 2 steps real quick here. All right, so here's my problem, K over 3 minus 9 equals 12. And our first step is to get the K over 3 by itself by adding 9 to both sides. It's a bad idea to say that they cancel. They do, but we're really adding opposites and getting the number 0 here. And when you add 0 to K over 3, you just get K over 3. 12 plus 9 is 21. And you are going to be very tempted to do the following. A lot of people see this K over 3 and they want to put 21 over 3. If you do divide by 3 on the right, you have to also divide by another 3 on the left. That is incorrect. We want to do the opposite to both sides. You must multiply by 3. This is a really easy error to make. The 3's cancel out. That's one of the reasons. And 3 divided by 3 is 1. I have 1K is equal to 63. You can see how people could get 7 out of that one. The next one. Which properties can be used to solve 7y minus 15 equals -29? Select all that apply. This is a really bad question. There's a whole bunch of things that could be chosen here, and I'm not even sure what they're looking for because, of course, you're going to use the addition property of equality. Let's do this the right way. Let's go ahead and write it. 7y minus 15 equals -29. You're going to use the addition property of equality by adding 15 to both sides. And we get 7y is equal to -14. And now I'm going to use the division property of equality and divide by 7 on both sides. And that is y equals -2. So I used the addition property of equality, which is in the list. I also used the division property of equality, and that is not in the list. And what they mean is the inverse property of multiplication. And you're also literally using the identity property of multiplication because 7 divided by 7 really is 1 times y. And since 1 times y equals y, you get the identical thing back when you multiply by 1. This is a terrible, terrible question for a whole bunch of reasons. We did use the addition property of equality. We did not use the distributive property. And we could have used the commutative property of addition if we wanted to, but we didn't necessarily have to. So this is a terrible, terrible question by Pearson. It should not be included. Of course, it will not count against you. Terrible, terrible problem. We'll move on. The square root of 95, where is it located on the number line? This is asking really for kind of interpolation in reverse. The way that interpolation works is that if you look at the perfect squares, that would be 1 times 1 is 1. I'll make my copy. Okay, so 1 times 1 is 1. There we go. 2 times 2 is 4. 3 times 3 is 9. Write the others yourself. Don't wait for me. 16. 5 times 5 is 25. These are called perfect squares. 6 times 6 is 36. 7 times 7 is 49. And what comes next? 8 times 8, hopefully 64 rings in your head. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121, and so on. Now, what they want us to do is locate where the square root of 95 is located. Well, we know that the square root of 95 is what number times itself gives us 95. And we happen to know that 81 is 9 times 9. So the square root of 81 is 9. We also know the square root of 100 is 10. So that tells us that the square root of 95 is in between these two. Hopefully you notice that it's quite a bit closer to 10 than it is to 9, because 95 is closer to 100 than it is to 81. Interpolation says that we kind of estimate this difference by looking at how far apart 81 and 100 is. Basically, this is 20 apart, and we're about 15 units along the way. Formally, it would be 9 and 15 19ths. But I'm going to call it 15 over 20. And 15 divided by 5 is 3 over 4. So I would say about 9.75 would be my estimate using more or less formal interpolation. All they want you to do is just locate between which two numbers it falls. Another way to do this, of course, is to square 7, which is 49, and 84. So is the square root of 95 located between these two? And of course, we can see that it's not. And between 8 and 9 would be the square root of 64 and the square root of 81. And we can see it's not between those two. And we should be able to notice that it is between the square root of 81, which is 9, and the square root of 100, which is 10. And since the square root of 95 is between those two, it must be this one. You're going to have a lot of practice with that, especially when we get to quadratics. You'll be expected to be able to estimate about this good. If I actually take the square root of 95, let's take a look at it and see what we get with our calculator. I get 9.7468 approximately. Now this keeps going forever because it's an irrational number, but notice how very close I came. I was within a few thousandths of the exact answer. And remember, this is only an approximation. So we'll keep going. Let's see what else we got here. Next one. Okay, absolute value says make it positive. A very, very common mistake is to get this right for the wrong reason. This is almost the worst thing that can happen to you, because if you get something right for the wrong reason, you keep doing that and you're doing it incorrectly. Now I'm going to show you the wrong way to do this, and then I'm going to show you the right way to do this. So let's take a look. This says that we're taking the absolute value of -3 minus 8. The wrong way to do this, is to say, oh, I'm taking the absolute value, so I'm just going to take the absolute value of both numbers. The -3 is 3, and the absolute value of -8 is 8. And then I'm going to take that absolute value of uh, 3 and 8, and I took the absolute value, so now the absolute value is gone, and I have 11. This is wrong. You can't take the absolute value first. You have to do the operation first, because absolute value behaves like parentheses. So if you take a -3 minus 8, you get -11. And when you take the absolute value of -11, you get 11. A lot of people said, well, I got the right answer, so it doesn't matter. Yes, it does matter, because if you put any other two numbers in there, one negative and one positive, it will not work if you add them together first. For example, -3 plus 8. Now, a lot of people are going to say, well, I'll take the absolute value. That's -3, makes it a positive, and I get 11, which is the wrong answer. This is not 11. The absolute value of -3 plus 8, if you were to do this problem, you would get -3 plus 8 is +5, and then you would take the absolute value, which is 5. Notice, be very, very careful. You must do what's inside the absolute value first, and then you can take the absolute value, which is to make something positive. Always positive. Which of the following is equivalent to the expression -24 plus 2 minus 10? Do not wait for me to do this for you. You should do this problem. It should literally take you less than a minute. If this takes you more than a minute, you're doing something wrong. I'm going to be writing it and explaining it, and it'll probably take about a minute. So once I get it written down, let's write it down. Come on. There we go. All right, we have the absolute value of -24 plus 2 minus 10. You have to do what's inside the absolute value first, and -24 plus 2 is -22. It's still inside absolute values. The absolute value of -22 is +22 minus 10, and I do the last step, and I have my answer. Like I said, even with a full, complete explanation, it shouldn't take you very long. The next one says the absolute value they want us to evaluate. Now, evaluation means that you are going to substitute and simplify. You're not solving anything. You're just going to substitute for y. So we have the absolute value of 2 and 5/6 plus y. And the trick for evaluating, there's always two steps. You substitute inside parentheses. I have 2 and 5/6 being added to y. Instead of y, I put the 7/4. Now, a lot of people are going to want to change this to a mixed number. Some people are going to want to make a decimal. A decimal is a bad idea, because 5/6 is 0.8333333, and it keeps going forever and ever. And 7/4 is a nice decimal. But when you add them together, you don't get a nice decimal. You'd have to redo it and make it into a mixed number. There's all kinds of problems going on. What I'm going to do is I'm going to go ahead and write them both as fractions. That's one possibility. So this one is going to be 12 plus 5, which is 17/6. and I'm going to add the 7 over 4. Remember, we have to do what's inside the parentheses first, get a common denominator, which happens to be 12, and you can finish up the problem. This is times 2. This one is times 3 because we want a common denominator. That gives us 34 over 12 plus 21 over 12. Now I have a common denominator. Be careful, the common denominator stays. And 34 plus 21 is 55. And you still have a final step. You still have to divide the 12 into the 55, which goes 4 times. And you have a 7 left over. And then you still have to take the absolute value. That's one way to do it. Now, if you wanted to make it easier for yourself, and the way that I would do it would be to leave the mixed number as a mixed number and change this one to a mixed number. So then I would have, this is the same, sort of equal sign here. I have 2 and 5/6 added to 4 goes into 7 one time with 3 left over. And what I would do is change these to twelfths and then add them together. Any way you look at it, you're still going to have problems because you're going to end up with, and let me show you what you get. You end up with 2 and 10/12 added to 1 and 9/12, which gives you 3 and 19/12. And that is an improper fraction and has to be changed. And of course, you get 4 and 7/12. And either way, you get 4 and 7/12. Some people are going to want to use a calculator for this, which would work. And as long as you could back out and find the equivalent fraction. You could also use estimation on this. This is about 3. It's a little less than 3. And this is a little less than 2. So when you add those together, you're going to get something pretty close to 5, but it's going to be a little less. And clearly, this one is a little less than 5. Estimation would definitely be the way to go on this one. All right. This is something we're going to. A lot of people want to treat this inequality kind of like an equation, and it is a bit like that. Let's take a look and see what we end up with. It says x plus 1 is less than 5. Now, if it were equal to 5, we could subtract 1 from both sides, and it just so happens that the subtraction property of equality is also a subtraction property of inequality. Inequalities, we are allowed to do this, and the inequalities keeps the same sense of the inequality. And this is a big theory that we're going to be going into in class. But let me show you what I did physically. What I did was it said that this thing right here was unbalanced. So on one side, I have x, I have a weight, x, that I don't know how much it weighs, and I have a weight of 1. And it says that it's less than 3. So in other words, this is an unbalanced scale. And I've got 5 weights down here. Notice that the 5 weights is heavier than the x plus the 1 weight. And what I did was I took this 1 off of here, which might have unbalanced my scale, but watch what happens now. I'm going to take 1 off of this side. Now, because I took the exact same amount off of both sides, the scale is still unbalanced, and x weighs less than the 4. And of course, we write it this way: x is less than 4. Now, if you look at your number line, you can see that all of these numbers are less than 4. And this open circle indicates that 4 is not a solution because it doesn't say it can be equal. If there had been an equal sign underneath it and it said x is less than or equal to 5, or x plus 1, then it would be filled in. Anyway, It just happens to be this one, and there's ways to test it. You could literally put any one of these numbers in there, and you're still going to get a number less than 5, and there are an infinite number of solutions for this, and there's your solution. I'm running low on time, and this is taking forever, so I'm going to move ahead, hopefully a little quicker. Which expression is equivalent to this? We're taking, keep going here. We're taking 1/3, come on, 1/3 x times 9y minus 12. This has to be distributed. Hopefully you know that 1/3 of 9 is 3, and you have an x times a y. All I did was multiply this 1/3 x times 9y. I also have to multiply the 1/3 x times the negative 12, which gives me negative 4, but the x is still there. So this is my solution. I just multiplied some algebraic expression. This is called a term times 2 other terms because this is a binomial, and I multiplied a monomial times a binomial. I'm using the distributive property and multiplying coefficients, and hopefully you recognize how that works. Let's take a look at another one. We're almost done. Which of the following statements is true if x equals -2 and y equals 8? So it says x and y, it says y is greater than or equal to x. Let's just substitute it in and see which one of these is true. Basically, they're going to change these to absolute values. So both of these are going to be positive. So is 2 less than or equal to 8? And it is true because we took the absolute value of x and the absolute value of y. That's the A one. So this is A, and it's true. B, we're going to take the absolute value of y, which is 8, and is that greater than or equal to the absolute value of x, which is 2? And that one is true. So the B is true. C says the absolute value of x, which is 2, is greater than the absolute value of y, which is 8. And this is not true, so C is out. And D says the absolute value of y, which is 8, is less than the absolute value of x, which is 2. And again, this one is not true, so you're only supposed to choose A and B. Number 15, the sum of x and 5 is x plus 5, and it's being divided by 12. And the only one is the very first one. They did it for you. Nothing much there. By the way, the IXL section for this is I1. Everybody should have done I1. And if you did, this is going to be trivial for you. The value of -8/9, if you take the absolute value, you make it +8/9. So it's C. 17. All right. We have seconds. Oops. This is messing with units. This is seconds plus seconds per something times days is equal to seconds. Well, clearly I need to eliminate the days by having days in the denominator, and they cancel out and give me ones, and I have seconds plus seconds equals seconds. This is sometimes called unit canceling. If you want to impress people, you can call it dimensional analysis. We're going to be using this throughout the course, and very often dimensional analysis is very, very useful in chemistry and physics, and we're going to be using it to simplify units and to do conversions. So if you've ever done unit conversions, hopefully you learned it this way. Most people don't until they get into physics, but you will be doing that in this course. And I want to move on. We have one last one, I think. Oh, this one is almost exactly what's coming in our courses. This is almost a literal equation. If I have C, sorry, one more time, last one. And you're going to have to be able to do this. If I have C equals 2 pi r, which it does, and C is equal to 24, what is the value of R? Well, I could solve this for R, which is what we're going to be doing. And in order to get R by itself, you have to divide both sides by 2 pi. And the pi's simplify, they divide and give you 1. 2 divided by 2 is also 1. And I have R by itself is equal to C over 2 pi. This is going to be an equation or a literal formula that you solve for. This is definitely coming this week. This is skill B. You're going to have to be able to do this. Now, the difference is they said that C was 24. So we're supposed to put the 24 in for C. And we're dividing by 2 pi, which can be reduced. 2 goes into 24 12 times. And you end up with 12 over pi. Now, the problem, of course, is that they should have reduced it, and they didn't. See, they left it like this. And they really should have reduced it to this 12 over pi. Anyway, there it is. I believe that was the last one. So we're finally done. Sorry it was so long, but wanted to go through all of those so you had a chance to get them right.